Good afternoon, I am Mr. Rish. I welcome you to this video here on trapezoids, but focusing here on angles of a trapezoid. I will try to make this subject matter fun, and we will try to break away from the concreteness of math and look at something slightly more abstract. When we're talking about trapezoid and the internal angles, we know we're looking at a quadrilateral, a polygon with four sides, and all quadrilaterals have the sum of internal angles equal to 360 degrees. In this video, we're looking at one question, but we'll get the two questions out of it by doing it in two different ways. Our question is this: we have to show two ways of determining that the sum of internal angles of a trapezoid are always equal to 360 degrees. So let's show you the first method of doing this, and we'll make this fun. We'll draw a trapezoid. We know a trapezoid will generally have two obtuse angles and two acute angles. How can we do this in one way? Well, how about we call this A over here, we'll call this D here, and we'll make this little rectangle here. It could be a rectangle or a square, it doesn't matter, but we know when we make these two perpendicular lines, we end up with right angles, don't we, right? These are right angles here. Here we got a right angle here, we have a right angle here. When we're doing this, after having done this, now let's call this angle B, let's call this angle C. We know A and B are complementary in the sense that they're within a triangle. A plus B plus this right triangle must equal to 180. If from this triangle right here, you have 190 already taken, we know A plus B here must equal to 90 degrees for its own triangle that it is in. Likewise, similar logic, we have a 90 degrees here, we have a C and a D. C and D are complementary in the sense that they'll add up to 90, and C plus D over here for this triangle must equal to 90. But we already know the fact that this right here is a 90 and this right here is a 90. If we were to look at this whole angle right here and this whole angle right here, these are two obtuse angles. These two obtuse angles are made of one 90 degree and another 90 degree. And then we also know A plus B is equal to 90. If we were to start separating angles out, this is how it'll play out. We have one angle A over here and one angle B, A and B. And then we have one C over here and one D over here, plus C plus D. And then we have over here this 90 within this rectangle or square, and then we have this other 90. And then I've already told you A plus B is equal to 90 because they're complementary. We know C plus D is equal to 90. So we essentially have four 90s, 4 times 90, 360 degrees. So this question has been completed utilizing this way. In the same question now, this is the second way of doing it. That'll be the conclusion of this video. Now for the second method, I believe this to be a little more interesting of a method. We again start with a trapezoid. Now what do we do over here? What we do is we draw these dotted lines and we convert the trapezoid into some form of a rectangle. You see this, you got 90 degrees here, 90 degrees here, 90 here, and this of course is a 90. What we can do is label angles. If we call this angle A over here, by means of this line and this line, these two lines are parallel to each other. Since they're parallel to each other, if this angle is A, this must be A. If we can call this angle A hypothetically, then this again must be A. But we know when we're looking at this part right here, from here to here, we're looking at supplementary angles, a straight line. A plus whatever this angle is, it must equal to 80, and A plus whatever this angle is, it must equal to 180. But then what must be this angle be? It must be 180 minus A. And likewise, what must this obtuse angle here be? It should be 180 minus A. So we have two acute angles which are designated as A. Then we have two obtuse angles that are designated as 180 minus A, because by means of these two parallel lines we end up having an A over here. But by means of the supplementary angle effect and the straight line being equal to 180, we find that each of these obtuse angles is 180 minus A. And then we add up these four internal angles. We have A plus 180 minus A plus another 180 minus A. Then you can add these up. The A's will cancel out. You'll end up with just a 360 degrees. And then this question has been completed utilizing the second part. I'll close off this video with this little hint over here. The sum of the internal angles for any shape is always equal to n minus 2 times 180. And that's something you can be tasked with utilizing on an exam, especially ACT or SAT. I've seen this come in. So remember this, however many sides are in a shape, n minus 2, the number of sides minus 2 times 180 will always give you the sum of the internal angles for that specific shape. And with that, I say goodbye. Thank you for watching. Have a nice day.